Welcome to Matematicas, anyone. Today I will teach you the integrals. Continue in a class of college calculus. Last time I show you the first part. Today I will show you the second part of the integrals. I divide my class in two sections. The first topic will be the midpoint rule. I will show you what I mean the midpoint rule. I will solve one example. And the second part, I will show you properties of the definite. Properties of definite. Also, I will solve one problem. All right. So, welcome to our integrals of college calculus. First of all, we have to understand the midpoint rule. We often choose the example point like with x like this. Always use the variable to be the right end point of the subintervals. It is convenient for computing the limit. So the midpoint rules is like this. Let me write the formula. We have a, b right here. So f of x differential of x, we will have like sigma. This sign is equals we have here I equals 1. So f like this sign that we always is a midpoint or average. That means this sign here 2 times increase x. Okay, equals increase x, open crochet like this. Let's write again x. I mean plus point plus let's write f times inside the parentheses just write like n right here. I mean the so on. I mean some number. Okay, this is the formula. Where here I will explain the formula in one problem. Where here increase x is equals b minus a divided by n. Okay, and let's write equals 1/2. Remember, we are talking about the midpoint rule. That's why I write this sign. And look at the formula. Is xi minus 1 plus xi here. This is equals midpoint of open crochet right here, xi minus 1 com right here is com xi. Okay, that's the midpoint rule. All right, let me show you one example, one problem. All right, let's go and solve one problem just using this formula. Okay, example. Example number 1. Let's write use the midpoint rule. The midpoint rule, the formula I show you, and then n equals 5. Now with values to approximate like 1 or 2. Look at this space. 1 divided by x differential of x, right? That's the problem. The solution, okay, let's see how solve the problem. So the endpoint of the 5 subintervalos, look at this, in the main point of the 5 subintervalos are let me write midpoint midpoint of the are I will write it right here. R1 com 1.2 com and 1.4 com 1.6 and 1.8 and 2.0. So the midpoint, so look at these numbers is 1.1, 1.1, 1.3, 1.5, what else? 1.7, 1.7 and 1.9, right? So the width of subintervals are the width is increase x equals we will have here 2 minus 1 divided by 5. So this is equals 105. 1 divided by 5, right? Yeah, because 2 minus 1 is 1. That's why, right? So the midpoint rules give us, I will erase this. I will erase all this data to continue, okay? Keeping in mind this. So what it says, the mid rule, the midpoint rule. So after this data, I will erase it. So we will continue. So the midpoint rules okay, so now we have to write the midpoint rules. Remember all data that is written before, so write it, the midpoint rules. We will have this differential of x equals increase of x. Just follow the rule. Here 1.1, okay, plus here remember the points 1.3. So checking back. What is the next one? Plus f 1.5 plus the f of 1.7 plus f of 1.9, right? That was the data, right? All information. So now here you are able to simplify. You will have 1/5. Remember, we got it 1/5 before, and the information before on this window. So times everything here, 1.1 here, plus 1.3, plus 1 divided by everything, 1.5, plus 1.7, plus 1 divided by 1.9. Okay, that's it. So this is equals here is 0.691908. Okay, that's it. Since here this is the solution, since I will not make a graph, just write it f of x equals 1 divided by x is greater than 0, and for 1 less or equals than x less or equals than 2. That is right here. See, that's the conclusion. Oh, you wanna make the graph? You can make the graph. It's very simple. Make the graph. It's not hard deal. Okay, so that's it for the midpoint rule. Next topic of the integrals which we are, or I am talking about, is the number 2. Topic number 2. It is about properties of the infinity. Of infinity. Properties of the infinity. So definite integrals. All right, because we are talking about integrals. So we have here, I will write some formulas. It is hot in here, okay? The formula, let's write the formula. We have the formula like this: f of x, differential x, it will be equals, we will have now inverse right here, change, f of x differential of x. That's a formula if a, in this case, equals b, right? This increase x, a equals 0, and so then we will have this formula f of x. Look at the formula. It's very simple. I will solve one problem like this. Okay, so this is in general, but I will write actually five properties. Let me show you the properties, okay? But this is the main thing. So the properties is let me write the number 1. I'll write all properties here. So the first one, we have AB right here. AB constant differential x is equals c times b minus 8 by where c is any constant. Where c is any constant. Right? So property number 2. Number 2, again, integral AB, but here we number 2 we will have here open crochet, f of x plus g of x, right? Differential of x equals integral. So integral AB, f of x, differential of x plus, again, AB, integral AB, gx, x, differential of x. Okay, it's number 2. Number 3, property number 3, integral AB, c, f of x, differential x equals constant. We have a constant right here. Integral AB times integral AB, f of x, differential of x, where again c is any constant. So number 4, integral number 4, we will have AB, open crochet, f of x here, minus g of x, close here, differential of x will be equals AB, f of x. Just write these formulas. I will apply in this formula in a one problem, dx. So here is equals, oh no, it's minus AB gx, differential of x. Okay, this is a formula number 4. Number 4. After this, let me show you one example. We saw one problem applying one of these formulas. Okay, take a look. The formulas here, properties of the definite integrals. So I will write two more for properties. Okay, 2 more. But at this point, let me show you one problem. Let's show you one problem. So example. Let's write use the properties of the integrals. Use the properties of the integral, of course, to evaluate it. So evaluate it. This problem. Here 4 plus 3x to the second power, differential of x. Okay, evaluate that problem. We have used the properties of the definite integrals, the first 4 properties. Solution. Okay, let's go step by step. Using the properties, we have to use the properties 2 and 3. Properties 2 and 3 of integrals. All right. If you use those properties, we will have, look at this. It's our problem right here. Let's write 4 plus 3x to the second power, differential of x equals. All right, so let's write integral 0, 1. We will have 4 differential x plus integral 0, 1, 0, 1, 3x to the second power, differential of x. And then this is equals, right? Plus, here we have plus, now equals, we have equals integral 0, 1 equals 4d differential x plus 3 differential 0, 1, again x to the second power differential x. Okay, all properties, the property 2 and 3 we know from the property 1. So now from the property 1, just check the property 1. We will have here integral 0, 1 from property 1 is 4d. I mean, for differential of x equals 4, 1 minus 0. So it's equals 4, right? So, and we found it in 5. We found it in 5 here. In 5.1, and before that we have this integral 0, 1 x to the second power differential x to the second power differential x equals 1/3. So we found it before. So then the solution is look at the integral 0, 1, a marker 0, 1 as we will have 4 plus 3x to the second power differential x equals 0, 1 integral 4 differential x plus 3. So integral 0, 1 x to the second power differential of x equals, now that's the solution. 4, we have 4 plus 3 times 1.3 7 is minus here. Seven. So this will be equals 5. See, 4 plus let's see, 4 this let's check this 4 1/3 4 7 1/3 I want to give the solution like that. This time right here, okay? Otherwise, not solution. All right. So that's it. I was a little confused in the project. Double check it right here. Okay. So that's it for our problem. Let me continue with more problems here. So next rule, we have another rule right here. It's a number 5. Rule number 5 is like AC. This is a constant f of x. This is another property. Differential of x equals CB f of x. Differential of x equals AB integral AB f of x differential of x differential x. So this is rule number 5. I will erase it. Okay, keeping in mind this rule is number 5. I will apply in the next problem. Okay, this rule I will erase it. So and write the example. So use the properties to integrals to evaluate it. We're going to evaluate it, this problem. Integral 0, 1. No, 0, 10. Okay, evaluate 0, 10 f of x differential of x equals 17, and also this one 0, 8 f of x differential x equals 12. All right, that's our problem. So we have to find A10 integral A10 f of x differential of x. So solution. All right, let's we have to use the property number 5. Property 5 here, which I write it a few minutes. Okay, property 5. You use the property 5, then we will have 0, 8 f of let's write x differential of x plus A10 integral A10 f of x differential x equals zero 10 integral 0 10 f of x differential x. Okay, it's right there, complete. So now you're looking for the solution. So we have then here a integral A10 f of x differential x equals 0 10 integral 0 10 f of x differential x equals here was it is gonna be minus 0 8 integral 0 8 f of x differential x, okay, equals 17 minus 12, right? Minus 12, 17 minus 12 equals 5, right? That's it. So that's the solution. That is very, very simple in this problem, okay? We already finished. Just apply the property number 5. Okay, that's it for this problem. Now we have to compare some integrals. Compare integrals. I will erase it our problem. Look, this very, very easy. This is the main formula. Apply the property number 5. Just simplify, and that's it. So the next part is a comparison. Comparison comparison of properties of integrals. So number 6. Let's write number 6. We stop at number 5. So number 6, if for instance, if we have f of x greater or equals than 0, now we're comparing for a less or equals than x, less or equals than b. See, then and integral ab is f of x, differential x is equals greater or equals than 0, greater or equals than 0. The number 7, if f of x greater or equals than g of x for 8 less or equals than x, less or equals than b, then integral ab f of x, the differential of x greater or equals than integral ab g of x, differential of x. Okay, that's the number 7. Number 8, property number 8, if f of x, just follow this as less or equals, here actually the measure, if m is less or equals than f of x, less or equals than m, capital letter, for 8 less or equals than x, less or equals than b, then we have m b minus 8 less or equals than integral ab f of x, of x, differential of x less or equals m times b minus a. Okay, all right, that's properties 6, 7, and 8. Now let me show you another problem. Work with this kind of the integral properties of integrals. Okay, so let's write estimated here. Use of course these properties. Use the property 8. Let me write right here. Use the property 8. Property number 8. Estimated integral 0, 1. We have e to x to the second power. Look at this, x to the second power differential of x. So use the property number 8. So solution is very simple. So we have, because f of x equals e minus x to the second power, a decreasing function, a decreasing on 0, 1, it is absolutely maximum. This is absolutely maximum value. So let's write m equals f of 0 equals 1. Is absolutely minimal. Is m, of course, f of 1 equals e minus to the negative, to the power negative. So that's the property 8. Property 8. So we have here e to negative 1, 1 minus 0, less or equals integral 0, 1, e to the x, negative to x to the second power, differential of x less or equals than 1 times 1 minus 0. So here is continue simplifying, is e to the negative 1 power less or equals than integral 0, 1 e minus x to the second power differential of x is less or equals than 1. See? So that's it. Since e to the negative 1 is some conclusion is so 0.3676, right? We can write simplify 0.367. Yeah, you can write 367 less or equals the integral 0, 1. This is in the way our conclusion, e negative x to the second power, right? Differential of x less than 1, right? Less or equals. Okay, that's the solution. Just applying the property number 8, the last property that I give it to you. Okay, so thank you so much to be in Mathematics. Anyone? I'm waiting for you next time. Thank you. Enjoy your life.